You are like अभी आगे हम लाइक आ गए ठीक है जी ठीक है सर
नमस्कार, एक बार फिर से आज के कार्यक्रम में आप सभी का स्वागत है। हमारे बीच हमारे मुख्य अतिथि हमारे पूर्व निदेशक डॉक्टर आर मुरलीधरन सर और आज के वक्ता प्रोफेसर अजय घटक पधार चुके हैं। मैं एसएसपीएल परिवार की तरफ से, निदेशक महोदय की तरफ से दोनों का हार्दिक स्वागत करता हूं, अभिनंदन करता हूं। आज एक अनूठा संगम है कि सीवी रमन सर और जेसी बोस सर दोनों का ही आशीर्वाद हमको एक साथ प्राप्त हो रहा है, क्योंकि राष्ट्रीय विज्ञान दिवस और जेसी बोस ओरेशन दोनों एक साथ हो रहे हैं। राष्ट्रीय विज्ञान दिवस का वक्तव्य हम लोग श्री दीपक कुमार मोहंती जी से सुन चुके हैं और आज के मुख्य कार्यक्रम जेसी बोस ओरेशन, जैसे कि हमारे रेजिंग डे की प्रथा है कि हमारे रेजिंग डे से एक दिन पूर्व हम जेसी बोस ओरेशन करते हैं। तो अब क्योंकि हम पहले से ही थोड़ा विलंब से चल रहे हैं, तो मैं आज के कार्यक्रम के मुख्य अतिथि और मुख्य वक्ता और निदेशक महोदया से अनुरोध करूंगा कि वे मंच पे आएं और मंच को गरिमा प्रदान करें। सर, मैम प्लीज। और आज के कार्यक्रम का डीआरडीओ के यूट्यूब चैनल पर सीधा प्रसारण किया जा रहा है, जिससे हमारे पूरे देश की प्रयोगशालाएं और बहुत सारे यूनिवर्सिटी और एकेडमिक इंस्टीट्यूशंस भी इसको सुन पा रहे हैं। मैं डायरेक्टर मैडम से अनुरोध करूंगा कि आज के हमारे मुख्य वक्ता प्रोफेसर अजय घटक का एक पौधे के माध्यम से स्वागत करें। मैम से अनुरोध है कि हमारे मुख्य अतिथि जी का भी एक पौधे के द्वारा स्वागत करें। मैं डॉक्टर पिका झा मैम से अनुरोध करूंगा कि वो डायरेक्टर मैम को भी एक पौधे के द्वारा उनका स्वागत करें। थैंक यू सर। जैसा कि हमारी परंपरा रही है कि हम किसी भी कार्यक्रम की शुरुआत ईश्वर की आराधना के साथ करते हैं और अग्नि को ज्ञान का एक स्वरूप माना गया है, तो मैं मुख्य अतिथि महोदय प्रोफेसर अजय घटक सर और डायरेक्टर मैम से अनुरोध करूंगा कि वे आज का कार्यक्रम दीप प्रज्वलित कर प्रारंभ करें।
अभिषेक आप भी आ सकते हैं।
धन्यवाद सर, धन्यवाद मैम. Sir J.C. Bose was considered as a polymath who was a pioneer in the investigation of radio microwave optics. He has made significant contribution to botany and was a major force behind the expansion of experimental science on the Indian subcontinent. Bose Galena detector was the first semiconductor device and photovoltaic cell whose significance was not missed by Walter Brittain, Nobel laureate in physics. Sir Neville Mott, another Nobel laureate, noted that J.C. Bose was at least 60 years ahead of his time, and in fact, he has anticipated the existence of P-type and N-type semiconductor, and which is the core working area of SSPL. He also designed the earliest waveguide and horn antenna, which is an integral part of present-day microwave engineering and astronomy. After joining the University of Calcutta as a professor of physics, Bose was denied access to laboratories due to his race, as the British Empire continued to assert its control over Indian educational institutes. He used his own money to fund his different research projects, as well as received funding and support from the social activist Sister Nivedita. He was on half salary as compared to his British counterparts, but protested to this, teaching without salary for 3 years. He was given full salary after 3 years. In 1895, Bose gave his first public demonstration of electromagnetic waves, using them to ring a bell remotely and to explode some gunpowder. In 1896, the Daily Chronicle of England reported that inventor J.C. Bose has transmitted signals to a distance of nearly a mile, and herein lies the first and obvious and exceedingly valuable application of this new theoretical marvel. Most notably in 1895, invited by Lord 1897, invited by Lord Rayleigh, Bose reported on his microwave, better known today as millimeter waves, experiments to the Royal Institution and other societies in England. In 1897, Bose speculated on the existence of electromagnetic radiation from the sun, suggesting that either the solar or the terrestrial atmosphere might be responsible for the lack of success so far in detecting such radiation. Solar emission was not detected until 1942, and the 1.2 centimeter atmospheric water vapor absorption line was discovered during experimental radar work in 1944. Experiment on plants regarding response and stimuli were possible because the design and fabrication of novel instruments like crescograph, photosynthetic bubbler, seismograph, etc. All of those were made in India, and most of them at Bose Institute. He was the first Asian to awarded a US patent in 1904. He and the legendary mathematician Ramanujan were also the first Asian fellows of the Royal Society London, as well as those of Vienna and Finland. He has been recognized by IEEE as a father of radio and wireless communication. 1.3 mm multi-beam receiver, now in use on the NRAO 12 meter telescope, Arizona, US, incorporates concept from his original 1897 papers. A crater on the moon is also named after him. So with these words, we start our today's program, and I invite now Director Ma'am for today's inaugural address. Director.
So as Abhishek has just brought out that we are fortunate to be celebrating both the National Science Day and the J.C. Bose Memorial Lecture on the same day, owing to the raising day that is happening tomorrow. So I think it's for us to take the inspiration from the works that they have done. And as Abhishek has just brought out about all that Sir J.C. Bose is recognized for, and how the world felt that he was 60 years ahead of the times. And about for the National Science Day, we know that the Raman effect that got discovered because of the plain curiosity of Sir C.V. Raman when he was traveling by ship back from Europe to India. These are the messages that is for us to absorb and say that we question whatever is told, and we keep our curiosity alive to judge and to discover the actual reasons behind what we are observing. I would just say that that is a message that we can take from the two inspiring personalities who we are remembering today. And it is so appropriate that we have the blessings of Professor Ghatak on such a day, who himself is so inspiring. And we have our former director, Dr. Muralidharan, as the chief guest, who has kind of led SSPL through a period of almost about 7 to 8 years. With this, my heartiest welcome to both Professor Ghatak and Dr. R. Muralidharan. And I'm so thankful for their consent to be here among us on this day. My heartfelt gratitude for that. So thank you very much. May I now request Dr. Muralidharan to introduce Professor Ghatak. All of us know, all of us, I mean, we are aware of the books. We know the name written on the books so very prominently. Yet it's a formality. We must go through his formal introduction, and for that I request Dr. Muralidharan to do so.
Dr. Seema Vinayak, Director SSPL, Professor Ajoy Ghatak, my colleagues, ex-colleagues and friends in the audience. I was given a very short notice to dash to Delhi. I was told perhaps on Friday, I think. I immediately consented to be here. Incidentally, Professor Ajoy Ghatak has given a Science Day lecture several years back in the other building. I recall distinctly. He has been on this occasion once earlier also. And it gives me immense pleasure to be part of the Science Day celebration this year at SSPL. Presence of a luminary like Professor Ajoy Ghatak makes this occasion very special. And he will be delivering the talk on Bell's inequality. And he is the most apt and appropriate person to deliver this. When I narrate his biodata, that will become very clear. The lecture series that is conducted every year is to honor the memory of J.C. Bose. I recall a couple of earlier lectures. One was by Professor Colin Humphreys on, I think, MOCVD of graphene, and one by Devdeep Jana of Cornell, who has been visiting SSPL often during every IW PhD. I think he gave his lecture on nitride electronics. This year, with the emphasis that SSPL is getting on quantum-based devices, it's appropriate that Professor Ghatak gives us a 101 on quantum theory. And this year it is very special because the Bell's inequality or the theorem got an experimental proof, and not this year. This year it got recognition. The experimental proof got recognition in the form of Nobel Prize. And Professor J.C. Bose, Abhishek mentioned his achievements. It's available all over the place. Every year we recall his contributions, and his contributions are very important as far as SSPL is concerned, because we work on millimeter wave devices and we should draw a lot of inspiration from Professor J.C. Bose. And SSPL, I was fortunate to be a part of the program on the development of materials and devices for use in microwave applications. Just to give you a brief overview, although the properties of semiconductor materials with which SSPL works on, and I have been working for the past now more than 40 years, and the devices are explained, and the performance of the devices are explained using theories based in quantum mechanics. That we all understand. We start with chronic Penny model, the wave equation, solution of the equation, etc., etc. It predicts the band gap, it predicts the band structure, and everything we get to know using the quantum mechanics principles. It is an indirect way that we see the electronic properties of materials, deriving their origin from quantum mechanics, and we indirectly test them using the experimental tools that we have. In the days when we were working on the materials development for quantum well-based devices, technologists called this a do-it-yourself quantum mechanics. They said you grow a quantum well, the eigenvalues, everything that you predict based on the band gap difference and the electron affinity difference, and then you calculate and then find experimentally we find the photoluminescence to be at that exact location after solving those equations. In fact, the use of wave functions and eigenvalues to determine the properties of the two-dimensional electron gas. For example, you have the triangular potential well, the eigenvalues. You solve simultaneously the Poisson equation and the Schrodinger equation to get the Fermi level, and then to predict the IV characteristics of the two-dimensional, high electron mobility transistors. If I remember right, Professor Ghatak and Tyagarajan published a paper in the early 90s on the calculation of eigenvalues in quantum wells in IEEE Journal of Quantum Electronics, which we used extensively to calculate the eigenvalues in quantum wells that we were attempting to grow using a 40-year-old MBE, which is now 40-year-old. That time it was not 40-year-old. And we saw that the indium gallium arsenide quantum wells predicted the photoluminescence properties of those quantum wells were on the dot using those calculations. You see these lasers, detectors, modulators in the fiber optic communication world, which is the backbone of the information revolution or the internet, and the high electron mobility transistors, which are at the heart of the communication revolution, like the mobile phone, 4G, 5G, anything that you take. Even if you take the gallium nitride transistor, there again you form a quantum well. Use quantum wells and solve equations to solve the Schrodinger equations to predict the performance. Although one may argue that quantum mechanics was at the root of modern discoveries, gadgets, and theories, but the hardcore physicists hold a view that proof of Bell's theorem inequality experimentally would be the test of quantum theory. The local realism, or whatever you may call it, nowadays you get a lot of information on that because there is a lot of applications involving this theory. And this this topic has gained immense attention. This year's Nobel Prize went to the scientists Alain Aspect, John Clauser, and Anton Zeilinger, who provided experimental proof of this theorem, not using electrons, but using photons. Nevertheless, this is an experiment. This is considered as this recognition is kind of proof that the Bell's theorem has been experimentally proved. If I am right, you may correct me if I am wrong. Maybe you will touch upon this in this in your talk. We are fortunate that Professor Ghatak, whose textbook on quantum mechanics is what I should say Bible or Bhagavad Gita to the students and scientists, and has been followed. Whomsoever I met in the afternoon who have studied quantum mechanics at the MSc physics level said that, yeah, Professor Ghatak is coming. We used to follow his book. And whoever studied at IIT said that how great a teacher he was and how we were fortunate to have him as a quantum mechanics teacher. So we are all very fortunate that he is going to explain to us or enlighten us on the topic of Bell's theorem. Quantum entanglement is the property in which aspects, for example, if you take spins of entangled pairs, they are always correlated no matter how far they are apart. This is one of the basis of the quantum theory, or what lies in between them. Even if they are in another universe, they'll remain correlated. That doesn't mean that they talk to each other. And this was at the heart of a controversy which he will also touch upon, which Einstein and others argued that there are some hidden variables, and all that argument you can follow on the YouTube lectures. There are umpteen number of YouTube lectures on this topic. And I think he will make that theorem, very lucid for us, and we will never forget it in future. About all this, I think Professor Ghatak will elaborate. This aspect of entanglement, why it is important? Because like we exploited the quantum bells and super lattices for making devices like quantum bell lasers, quantum cascade lasers, or two-dimensional electron transistors, this entanglement is at the heart of modern, what is known as the quantum mechanics-based devices, like what we call as quantum sensing, quantum encryption, or quantum computation, etc. So every other day there is a news item that such a company has passed a milestone in quantum computing. We get to hear that DRDO has launched a program in quantum related applications, and I am glad to know that SSPL is a partner in this program. Now I come to the formal introduction and of Professor Ghatak. I have great pleasure in introducing Professor Ghatak. He did his MSc from Delhi University, PhD in Cornell, then he became a professor at IIT, and till 2006 he was a professor at IIT, and he held large number of visiting professorships in many of the universities, leading universities in Australia, in Europe, and in US. And he is recipient of the Bhatnagar Prize and then he is an SPIE Educator Award, and also the Galileo Galilei Award, and the Heller Award instituted by Optical Society of America, and many more. And he was the president of the National Academy of Science. As you can see, his enthusiasm is contagious. The moment you sit with him, you will get to learn a lot of things, and he's a great teacher, as I have already told you. And he once led a vibrant group at IIT Delhi, which laid the foundations of fiber optics research in India. Just now I was talking to him about his colleague, Professor Tyagarajan, who was partner in that development. And he has published 19 books, and some of them are optics. I'm quoting only 5 of them: optics, lasers, fundamentals and applications, quantum mechanics. And in the year, I think 22, he published a book, Einstein's Year of Miracles, E is equal to mc square, light, quantum and special theory of relativity. So we are fortunate that he agreed to deliver the J.C. Bose Memorial Lecture this year on evolution of quantum theory and simple derivation of Bell's inequality. Over to Professor Ghatak.
Dr. Seema Vinayak, Dr. Muralidharan. It is my great pleasure and privilege to be in this famous laboratory to deliver this very important lecture, Jagadish Chandra Bose Memorial Lecture. I am very, very happy to be here. I have been given about 55 minutes. I hope I do not exceed that. But Abhishek and Dr. Muralidharan have already helped me in telling a lot about Dr. Professor Jagdish Chandra Bose himself. So I will not give more details. You already are aware of it. On the top of this slide, you see the photograph of Professor Bose, and I will probably show one more photograph during the course. Once again, it is really an honor to be here in front of this distinguished audience. This is going to be an elementary talk. A large number of you are already PhD in physics, so I will give a very simple account of quantum theory. But before that, because today is a science day and we will speak something about the times of Jagadish Chandra Bose. So I thought I will tell you a little bit of history, which will be known to all seniors sitting here. But the younger generation should also be familiar with what we have achieved and what was that due to. So I will try to explain that. And so let me go to the history part for about 10-15 minutes. You know, the iron pillar near Qutub Minar in Delhi was built in the 5th century, 1700 years back. It appears to have been protected from rust by the application of a thin coating of manganese dioxide. So the thin film technology existed 1700 years back. So we were really very advanced in the construction of bridges, in constructions of this iron pillar, and even civil engineering. The temples that are old, the architectural beauty of that is really tremendous. Then we had Nalanda University. Jeffrey Gatton in New York Times wrote that Nalanda University was founded in the 5th century, 1700 years back, and was one of the great universities in recorded history. The university was an architectural and environmental masterpiece. At the peak, it had about 10,000 scholars and students, and from different parts of the world, like Persia, China, Japan, and everywhere. People came over there to study. So we were at the center of this world, and that was 1700 years back. And as most of you would know, this was burnt down around 1197. There is a history behind it. I will not go into the history. But then after this came the dark period in India in the development of science and technology. Before that, the science and mathematics was where we were very advanced. The whole belt from Japan to China to India to Middle East. The first book on optics was written by Al-Hasan, who was in Mesopotamia, now in Iraq. And that was exactly about 1,000 years back. And 2015 was celebrated as the Year of Light because Al-Hasan wrote that book in 1015. So then after that, after about year 1100, came the dark period in India, where the development of science and technology did not take place. There was development in literature, music, and other things, but not in science and technology. This was also the dark period in Europe, but then very dark period in Europe, where Bruno said that it is the earth which goes around the sun, which was against the scriptures, and he was burnt alive. And Galileo was also imprisoned. So the religion played the most important role, and that was a disaster. So, but then came Galileo and Einstein and Newton, and there was the Renaissance, and which was followed by the Industrial Revolution in Europe, which started around 1760 and involved, for example, going from hand production methods to machines. The Industrial Revolution did not take place in India. 1760, the Industrial Revolution took place in Europe, but not in India. It was only in 1817, about 200 years back, the Hindu College in Calcutta was formally opened with 20 scholars. This was the first institution of higher learning in the modern sense in Asia. The foundation committee of the college was headed by Raja Ram Mohan Rai, who along with 6 others donated their personal wealth to establish the college. That is the most important thing. Philanthropy, that is the most important thing. They donated, they begged from the rich people to give money to build colleges. And this came to be known as the Presidency College, and in 2010 it became Presidency University. The pioneering discoveries of Jagadish Chandra Bose in physics and plant physiology and of Prafulla Chandra Ray in industrial chemistry were made in the laboratories of Presidency College. Prafulla Chandra Ray was also a great chemist, and pharmaceutical industry was started by him. All of us should remember that. And that was during the British period. And as was mentioned by Abhishek, the receiver that Jagadish Chandra Bose designed, he opened it up. He did not patent it. Actually, Sister Nivedita had forced Jagadish Chandra Bose to patent his discoveries. But at that time, he did not patent it. And the story goes that Marconi got that design from him, did not acknowledge. Eventually, he created his communication system, for which he got the Nobel Prize. And many people feel that Jagadish Chandra Bose should have also received the Nobel Prize. But that is not important. But the main thing was that in pre-independent India, we had scientists like Jagadish Chandra Bose and Prafulla Chandra Ray. After the Presidency College, which was started as a Hindu college, it was not for Hindus, it was for everyone, but it was named as Hindu College. Agra College was founded in 1823 by generous public contributions, not by the government. And it was founded by the Sanskrit scholar Pandit Gangadhar Shastri long before the first university in India was established. I particularly mention Agra College because I'm very proud of that. I spent 4 wonderful years there. I did my BSc there. Then in 1857, 3 universities were set up. This was set up by the British. British did a lot of, this is also getting recorded. Yeah, they did a lot of wrong things in India. They exploited us. They came to exploit us. That is established. They came to exploit us and they exploited us. But at the same time, they also did a large number of good things. One that everyone reads in the newspapers, the Indian Penal Code, that was established by the British. And general law and order, the civil administration, that was also established by them. So we should see the plus and minus points of everything. So in 1857, they set up 3 universities in Madras, Calcutta, and Bombay, similar to the structure of University of London. Madras is now known as Chennai, Calcutta, Kolkata, and Bombay as Mumbai. And then in 1869, not in 1969, 1869, there was this great visionary and philanthropist. Philanthropy has to come into our country in a very big way. Dr. Mahendralal Sarkar, who was a medical doctor, actually a homeopathy doctor, very rich person, he wrote, and read this carefully, that the prevailing backwardness of the country was due to backwardness of science, and that the solution was in the vigorous pursuit of the sciences by original research. I say that read this carefully because today also this is valid. Today also 30% of our population is below the poverty line. That's a staggering 400 million people. 400 million people. Even if it is an overestimate, maybe 300 million people or 250 million people, definitely, they are below the poverty line, in spite of the tremendous development that has taken place. So, everyone sitting in this room, including myself, should consider extremely fortunate to be here. We are a poor country. At all stages, we should remember that. And what is the solution? What is the solution? He said through only science and technology, And on 9 July 1876, he founded the Indian Association for the Cultivation of Science at Beaubazaar Street, supported by generous public contributions. And it is here, as you all know, C.V. Raman did his Nobel Prize winning work and on Raman spectroscopy. Here I will make a controversial statement. On 28th February 1928, exactly 96 years back, hear this carefully, K.S. Krishnan discovered Raman effect. It was K.S. Krishnan who had seen the Raman shift and saw that this Raman shift of spectral lines due to the molecular vibrations was independent of the frequency of the incident light. So he told this to Raman, and then Raman immediately realized this. He wrote a paper in Nature. He acknowledged that the measurements were done in that. I have that paper. He acknowledged that Mr. Krishnan has done these experiments, but he had himself only as the author. And then it is said in one of the books that in the Nobel Committee, people said that Krishnan should also get the Nobel Prize, to which the comment was that Krishnan was not nominated for the Nobel Prize, and therefore C.V. Raman got the Nobel Prize. So that is history. And then in the early part of the 20th century, Jamshedji Tata donated his personal wealth to the tune of 30 lakhs in 1900 or 1901 to create an institute. He was inspired by Swami Vivekananda. He was going on a ship to Vancouver and with Swami Vivekananda, and Swamiji asked him that what takes you to America? He said, I want to bring steel industry. And as you all know, Jamshedpur is famous for the steel industry. And he said that Swamiji said, he was a monk, no training in science, but he had the vision. He said that you also set up an institute where research is done in this area. That is the greatness of Swami Vivekananda. Inspired by Swami Vivekananda and others, and his own personal vision, Jamshedji Tata set up the Indian Institute of Science at Bangalore. And I have no hesitation in saying, although I'm very proud of IIT Delhi, but IISc Bangalore is the best institute in our country. So then in 1917, Jagadish Chandra Bose, in whose memory we have today's lecture, he set up the Bose Institute. Actually, he started it as Bosu Vigyan Mandir. And he donated several lakhs of his own personal money to set up this institute. Then Swamiji's disciple, Sister Nivedita, had a contact with Mrs. Sarah Bull, who donated a large amount of money. The government did not give money. Today, whatever we do, we want government's money. The government did not. He set up that institute with his personal wealth, and then other people. Rabindranath Tagore convinced many rich people in Kolkata that you donate money for science research. So you see, Rabindranath Tagore was a great, one of the outstanding poets, one of the outstanding songwriters, one of the outstanding composers. Brilliant. So, but he was totally an arts person, but he saw the vision of science and science education, science research. That is very important. That is important today. I hear that the grants are coming down, the research laboratories are, it pains me tremendously. For the upliftment of the society, you have to have a vibrant education system, research system. And look at these visionaries, Mahendralal Sarkar, Bose Institute, and Jagadish Chandra, Jamshedji Tata, and many others, and Gangadhar Shastri. They all set up educational institutions, not for making money, not for making profit, but for the cause of basic research. And so we have had many great scientists, engineers, healthcare workers, like many others, C.V. Raman, Vanjalal Sarkar, Ashutosh Mukherjee, K.S. Krishnan, D.M. Bose, Bibha Chaudhary, Meghnad Saha, Satyendranath Bose, S.S. Bhatnagar. Ramanujan was a genius. Ramanujan was an exception, in my opinion. He was a genius. He would have done this great work even if he was somewhere else. But others were motivated created by the system that was created by the British. So Prashanta Mahalanobis, who created the Indian Statistical Institute, the Homi Bhabha, who created the Atomic Energy Program, and then Vikram Sarabhai, the space program. So because of that, and of course many, many more of the scientific base, we have achieved a lot. Let me go through that quickly, what we have achieved. We have a flourishing space program. In 2017, ISRO created a world record by sending 104 satellites in a single rocket. That was the vision of Abdul Kalam, Vikram Sarabhai, and Satish Dhawan. And then we had the Green Revolution. We had the White Revolution. When I came back from USA in 1964, and I got married in 67, I had a son in 69. Milk was not available. I don't know how many of you will remember. Milk was not available. And Delhi milk scheme, I had to work very hard to get an additional liter of milk every day. So it was one man, Varghese Kurian, who had this milk revolution, nuclear energy revolution, vision of one man, Homi Bhabha, then Ramanna, then many others. Then solar energy revolution that is taking place right now, which is the vision of our Prime Minister. And then the communication revolution that has happened. That is a tremendous. Today, internet is the cheapest, one of the cheapest in India. And because of that, even our Sabziwala, they also have a smartphone. And imagine what we can do with this smartphone. You can get money from your brother in USA and instant supply. I used to fill up money orders for people. I remember that. Many of you would not have seen that. That today, communication, I can talk to my son in USA free of cost. I can see him. So this is a revolution that has happened. And it is free, almost free. And that is the vision of one person, Sam Petroda, I think. And I had known him personally. He made me a committee member. Well, that was another story. And then smart moves have been so successful in education, transfer of money to remote, etc. Revolution in engineering. I never thought metro will be there in Yusuf Sarai and Sadar Bazaar and things like that. But it's a revolution in engineering. And India is the largest producer of vaccines. So we have achieved so much. But then there is poverty. That each one of us sitting in this room should remember. This is a slavery in a brick manufacturing company in India. There is tremendous poverty in Rajasthan, UP, Bihar, Odisha, and other places, Andhra Pradesh. And then even in the nation's capital, people have been dying in the cleaning our sewers. It's a disgrace. It's a disgrace. So, and India ranks 107 in spite of all the things that we have achieved. We in the global hunger index, we are still behind Pakistan, Bangladesh, and Nepal. This is also very embarrassing. The question is, in spite of our great achievement, where did we go wrong? What is the solution? In my opinion, in my humble opinion, the solution is only through education, science, technology, education of women, eradication of corruption, values imparted by parents and by school and college teachers. Now, this is very important. Today, we have the least respect for the school teacher.